Once upon a time, there was a zookeeper who missed her elephants during quarantine. To cope, she watched a lot of Dumbo. When she finally returned to work, she decided she wanted her elephants to have big ears like Dumbo, so she selected the top 10% of elephants with the largest ears and bred them. However, she knew that in order to properly improve her elephant population, she would have to use quantitative genetics. She knew that her broad sense heritability was 0.85 and her realized heritability was 0.67. She also knew that her current population of elephants had an average ear width of 48 inches and a standard deviation of 6 inches. She used this information to find the information that she needed. First, she had to find her selection differential. The equation for this is S equals I times standard deviation. In our case, I is 1.755 since we are selecting the top 10%. Then we times that by 6, which is the standard deviation, which gives us 10.53. Next, she found the mean of the selected parents by adding the selection differential to the original mean. In our case, that's 10.53 plus 48, which gives us 58.53. Then she found the truncation point by doing the original mean plus z times the standard deviation. In our case, that's 48 plus 1.282, since we selected the top 10%, times 6, which gives us 55.692. Next, she found the response from selection by doing the realized heritability times S. In our case, that's 0.67 times 10.53, which gave us 7.0551. Finally, she found the mean ear size of the offspring by doing the original mean plus R. In our case, that's 48 plus 7.0551, which gave us 55.0551 inches. As you can see from this graph, the graph of the offspring has been shifted right from the graph of the original population. You can also see that the mean of the offspring is greater than the mean of the original population. This means that our experiment was successful. This graph also shows the selection differential, the mean of the selected parents, and the response from selection. Although this experiment was successful, eventually, if we continued, the elephant's ears would become too large and the trait would become detrimental, which would mean that it would eventually slow down and we would no longer see an increase.